Okay, remember this lecture is about heuristics and problem solving. And we took a detour and talked about perception and heuristics used in perception. And that's because perception is kind of solving a problem, right? You're solving a perceptual problem as opposed to, I guess, an analytical problem. Or yeah, there's still perceptual problems are still problems, right, to be solved. And so we're going to go back to more about problem solving separate from perceptual problems. And so Newell and Simon, right, their idea of an initial state, a goal state, and operators to use to get through a search space, there was really two flawed assumptions. Um, and remember that their goal was to make a general problem solver. So it's something that could solve problems in general. And they started by picking problems that they thought were the kinds of problems that are characteristic of human intelligence. Uh, and for them to do this, right, for this to be possible, they assumed that all problems were needed to share some attributes that were similar enough to each other on some deep level for them to be solved. So they assumed that all problems share a set of common features, right? So even though problems vary a lot, at their core, there must be something that connects all problems to each other, right? Um, this is probably not the case, right? So that's one flawed assumption. However, a much larger problem was that for many problems, figuring out how to formulate the problem is often the hardest part of problem solving, right? So, sorry, I forgot to go back. They assume that problem formulation, formulating the problem, is the easy part of problem solving, right? So knowing that what the initial state and what the goal state is and what the operators are, that this was very easy. And the hardest part was the sort of computational aspect and the searching through the space. Um, but that, but really, if you think about a lot of problems, the formulation of a problem is the most difficult part, and we'll talk about that more in a second. Yeah, so when many of these problems were given, well, sorry, I already said that. So when many of these problems were given, the initial state and the goal state and the operators are often presented to you in an obvious way, right? And Noel and Simon essentially assumed that this is how problems are. Um, so like when I give you a when you get a math problem, usually the goal state is to solve for X or something like that, right? It's just the goal state is totally given to you. It's very clear. Uh, and so what do I mean by problem formulation? I mean that figuring out the initial and the goal state, as well as the relevant operations or transformations, uh, that is what problem formulation is. And in a lot of problems, yeah, okay, it's very obvious what the initial and the goal state is, as well as the operators, but that's not always the case. So again, this probably doesn't make sense now. So let me give you some types of problems to illustrate this. Um, okay, so there are different types of problems. So in order to talk about, uh, um, you know, problem formulation, I need to introduce types of problems. There's well-defined problems, right? And then there's ill-defined problems, right? So well-defined problems are problems in which the initial and goal states are clear as well as the operators. This is either because these things are explicitly given by the problem or because the problem has enough constraints that it is reasonably obvious what you need to do. These types of problems include math problems, logic problems, chess, the Chinese game Go. Though there are many other problems like cannibals and missionaries, as well as the traveling salesman problem is also those two are also well defined. Um, However, many of our day-to-day problems are ill-defined, so meaning that it is not clear what the goal state is, nor maybe it's not clear what the relevant operators are. What tools do you have at your disposal? For example, what does it mean to find happiness, or plan a good city layout? What tools, operations, or transformations could you use to achieve it? This last question applies to most ill-defined problems. Right, so in a well-defined problem, it's very clear what you can do or not do. If it's a math problem, you often know what math operators you should use. If the problem is 55 plus 77, the operator is literally just the plus sign, right? Addition, which indicates that you should add. The cannibal and missionary problem is, you can only move one or two creatures at a time, right? You knew that you couldn't simply build a dam, that you didn't, you knew that the problem wouldn't allow you to just build a dam in order to deal with the river. You know that you shouldn't take the derivative of the boat or move uh, one of your cannibals to F3, right? I'm saying this sort of tongue in cheek, right? The point is you can't do that, right? It is very clear what the transformation is that you should be doing, the operator. This is because the problem is so well defined by the constraints of the problem. Uh, even if they weren't, explicitly, even sometimes they're obvious, but if not, sorry, sometimes they're explicitly communicated by the problem, but sometimes they're just quite obvious, right? And such constraints might be important to solving an ill-defined problem, but they are often not obvious. Like, in other words, there may be an initial state, a goal state, and operators involved in an ill-defined problem, but they just aren't particularly salient, right? Um, so I think of two types of ill-defined problems, some that you do not have a clear criteria for a solution, and some in which you do. Now, the first kind of ill-defined problems are problems like associated with policy making and design, right? Like, what's the best policy regarding moderation on social media? Of course, one could have heavy moderation, but that could lead to less engagement, which, if you're the person making money, that's great, but or sorry, that's bad, right? But to everybody else, maybe it's not. But so if there's heavy moderation, it could lead to less engagement. It could even lead to weaponization of moderation, right? You could have light moderation, but that invites a number of other problems, such as harassment and hate speech, which also might reduce engagement or scare away advertisers. So the point is that sometimes it's not clear what the goal state is, right? However, there are also ill-defined problems that look well-defined, but they aren't. And so now I will introduce an example of that, right? So we're talking about ill-defined problems. Actually, I'm going to do this on the next video. Yeah, we'll talk about ill-defined problems that look well-defined, right? Meaning that the solution is obvious, or the goal state is obvious, but it's not obvious, I guess, what the constraints are.